Okay, let's get to it. The idea behind this meetup, I literally came up with it in a conversation with our organizers saying, we don't have an August topic. What are we going to talk about? And I thought, well, you know, this weekend, I just randomly searched for Unity examples, and I found this Flappy Bird tutorial. So that's where we are. Disclaimer, I am not a gamer. I am not a Unity full-time developer. I'm not a Unity expert even. What I'm gonna present here is that this is something that anybody could do. This is not, okay, you know, you need to have some basic logical programming understanding, but Unity is so easy and simple to do. It's one of those things that I gotta say, I don't know why everybody's not doing it. Because, well, I'll get to it in a minute. So we're gonna talk about how to start a Flappy Bird clone. You might say, what is a Flappy Bird? Well, if you didn't know, Flappy Bird came on the market like what, 3 years ago, 2012-ish, 2013, I don't know. And it's just a game where, I mean, this is a copy. This isn't the real thing, but it's a really, really simple game, but it's actually kind of surprisingly hard. And because it's difficult, you know, I just can't ever get past like 3. Because it's difficult, it's kind of addictive because you think, that can't be that hard. I can surely do this. And I mean, I'm going to do it right in front of you because I know I can do better than that. Oh, darn. Okay, yeah, so the thing is, you know, it's kind of addictive because it's so simple. And you might say now, well, why? That's why. Because like a month after the South Korean guy had put it up for just on the Play Store. Actually, no, that wasn't a month later. I think he put it on the Play Store and on the iTunes like in October of 2012, I think. And then in May of 2012, somebody discovered it. Maybe put it on social media or something like that. And 1 billion people downloaded it and started playing it. And it had, you know, ad revenue kind of stuff in it. So all these commercials were playing to these users and paying back to the developer. And it was $50,000 a day in ad revenue. And there's rumors that the guy got threatens for litigation from Nintendo and other people because his stuff looked kind of like Mario Brothers. He later denied that and said that wasn't true, but who knows? In other words, the reason why you might want to do this is because it's really easy to do. And okay, you know, there are complicated parts about it, about, you know, getting together an app that pays the developer for showing commercials. We're not going to get into the complicated stuff. I'm just going to show you how you can throw together an app that moves something from left to right and you control it. The ad revenue is outside the scope of what I'm going to cover. So, you know, sorry, that's maybe that's next month. We'll do that next month. If you want that, we'll cover it next month. Okay, so how? There's, you know, a bunch of different ways. Like, okay, you could teach your kid how to do this in an hour of code. And if none of you have seen this and you think it's worthwhile, if you think your kid might like learning this stuff, go to code.org and check it out. And it teaches kids how, basically building blocks of logic. It's, and if you Google hour of code Flappy Bird, you'll find it. But I think it's on code.org. And the nice thing is you basically just drag blocks around, saying move left, if, and you can put it in a little event handler, if user touches space, then flat, and it goes left to right all the time. So, you know, it's really easy to do something like this, and Hour Code can help you and your kid do that. Another similar language is Scratch. And it might even be what the Hour Code thing is based on. Again, it's a visual development where you drag blocks saying, if this, then do this, otherwise, whatever. But the one, and there's a complete tutorial on YouTube that, do I have a link? No, I don't have a link. But what I'm going to be covering is developing in Unity. I said a little bit of it earlier. Developing in Unity is very simple. I'm going to be presenting it. It's going to be awkward because I'm not a Unity expert, and I'm kind of going to be trying to put it together in front of you, which is always weird. I'm not going to run it like a code lab with everybody trying to do it at the same time because that's just too awkward. We can do that if anybody is really interested. Otherwise, I've already posted the link to the online tutorial that I took this stuff from on the meetup page. So if you're actually interested and you want to do this like on your own, no problem. Or you can even just download their finished code from Noobtuts, Noobtuts, I think it's whatever, .org. They have this online project with, I think it's got a zip file with all the Unity assets and code in it. From there, I'm actually just going to dump the code. And I'm going to do it on a couple of different computers, so forgive me. You see this one, you don't see this one over here. This one's notes over here.
So Unity is just a different coding language?
Unity is an IDE. And it uses, among other things, like it does you do visual programming, like dragging and dropping, stuff like that to put your things where you want them to be. But usually when you're doing code, the actual written language to do stuff, it's in C#. And a lot of people are going to think that's kind of weird, but one nice thing about C# is it's really flexible. And if you know Java, you basically know C#. So let's get into it. Unity, yes. Yeah, I mean, I think the target developer for Unity is game developers. And if you go to unity.com or whatever it is, I mean, you find it. You'll see demonstrations on how to write this game or that game. And everything from first-person shooters to, two-dimensional planar left to right things like I'm going to be doing. So I'm going to, okay, first off, let me just show you. This is the product that I'm going to be putting together. And you'll say that doesn't look like Flappy Bird. Well, no, it doesn't. It's my Flappy Bird. So oh no, see, you can't lose it, my Flappy Bird. Oh, you know what? Look here. Look here.
What have you done?
This is not Flappy Bird. This is Flappy's revenge. This is Flappy saying, "I'm not taking this anymore." So I don't know if I'll ever put anything like this on the App Store. This is me proving that I could do it. But what you see right here. This is kind of the product of the online tutorial that we start from. All you really get is this little plane, and you get a bird that flies left to right over it, and you get a couple of obstacles. What I replicated was that, or what I changed in it was that he can go also left instead of just right, and that he doesn't die when he touches the pipes. Because that always ticked me off that it just dies. Okay, maybe it's the object of the game, but I want to be able to keep going. I guess I'm not a millennial or whatever, but millennials don't like to lose games. We like to keep going. I'm 43 years old, so I'm not a millennial, but whatever. Okay. Did I say I'm 43? I'm 33. Yeah. Okay.
There you are.
So I'm almost a millennial. No.
Moving along.
Moving right along. So we're going to open a new project, or excuse me, create a new project. File, create new project. And we're going to call it Flappy, if I can type, Bird Demo. Create project. That's for the old one. And you know what? I didn't, I don't know if I said, yeah, I picked the wrong framework. We're going to make it 2D. And because I just did that idiotic thing, I'm going to call it Flappy Bird Demo 2. And it's got to be Unity 2D, create project. It's running through its prefabs. Okay, so now we're going to go, the way that this works is it automatically places a camera onto your scene, and this is, it's going to be a scene that has visual artifacts in it, and your lens that's focused on it is this camera here. So we're going to select the main camera in the hierarchy, which is right here, and we're going to set the background color to light blue. Let's say 198, 208, 230. Nice light blue color. And here. So what that's going to do is everything beyond like what we draw the graphics is going to be on that background, and it's just going to be this nice light blue color. Okay, we're going to begin by drawing a very simple sky background on our drawing top tool of choice. And in the tutorial, which is, like I said, noobtuts.com, they have these images to start the thing. And right here, I'm going to save this image here so that, you know, is on the page. Put it in development, Unity, like Bird Demo 2, assets, and I'm going to put it into a sprites folder. Okay, go back into Unity, and go into the project and find what we just saved, and it automatically identifies the things that are new. And we see our image here. There it is in a kind of an inspector. Go into the inspector, and we're going to set pixels per unit to 16. And this is going to be basically the unit size of like when we tell our bird to move 1 unit, that means it's going to be 1/16 of this background. Filter mode, we're going to make it point, and you just got to assume that I'm doing the right thing. Format true color, apply. Okay. Now, we're going to take that background and drag it onto the main camera, and it becomes a child of the main camera so that it's always there. Okay, now let's take a look at the inspector and position the background sprite that we just placed in there 1 unit lower at y equals -1. Okay, that's just so that the background doesn't look just a little bit too high. It's kind of centered on the on the camera. Now, if we press play, you're not going to see a whole lot. You're just going to see, this is what you would see if you were in the game right now, and you guys got to assume that it's running. Trust me on that. So now, there's one more adjustment to be made. We're going to add the bird and small soon, so let's make sure that the background is really drawn behind everything else. So we need to go back into the inspector here and select the order in layer and set that to -1. And that means it's going to be behind the other, or unless we put the other items in the scene lower than -1, they're going to be in front of that. Okay. So now, oh yeah, and just to clarify that a little bit, the higher it is in the order, the higher the number, the closer to the camera or the viewer it is. Okay, now the ground. On that same tutorial goes on, and there's another image here. I'm going to save this and put that in the same sprites folder. We're going to call it ground.png. Again, you can do all this yourself. I'm just here as a medium. We're going to change the import settings on that ground sprite the same way. We're going to set the pixels per unit to 16, so it's the same as the sky. And filter mode to point, format, true color. Okay, did I do all that right? Okay, now take a look at the inspector and position the ground at, oh yeah, first we gotta put the, hey, are you doing this? Yeah, we gotta take the ground and put this into the scene. It's not gonna be a child of the main camera, because when we have the camera move, we want the ground to stay stationary, so that, you know, as you scroll this way, the ground doesn't go with the camera. So we're going to put that right there. And unfortunately, it's kind of centered. We don't want it centered. We're going to set its X to 16 and its Y to -6. So, you know, it's down lower on the screen now. Now, this time we're going to set the order in the layer value to 1, and that way it's kind of in the foreground of where we of the camera. And if we put the sprites on the scene, the ground will be up in front. Okay. Now here we have to get into a little bit of the physics, the physics simulator that Unity runs. We're gonna end up put something in this world, and when that something's in the world, when it hits the ground, we want it to stop, right? So in order to do that, we have to give the ground some kind of property that tells Unity to make it stop. And you could either do that programmatically and just have a script running that says anytime you get to this Y level, stop moving vertically. But it's a lot more, makes a lot more sense to have it do it with the physics. So we're going to go into this inspector here and say add component and say physics. It's under physics 2D. You find, is it rigid body? No, physics 2D, box collider 2D. Box collider 2D. Okay. And normally we'd be done, but there's one more adjustment to be made here. Later on, we'll add obstacles to our game, and those obstacles will move upwards and downwards into the ground. And because you saw what I first put on, where the little columns going up and down, when they hit the ground or when they went to the vertical level of the ground, they didn't bounce because, well, basically we don't want them to. So to have that to have the two things in the same world not physically interact, we have to give the ground a special kind of physics. So what we're going to do is, and it, you know, there's a bunch of different ways to do the same thing, but that's how we're going to do it. We're going to go into the inspector and add a new layer. Right now it's in the default layer. And we're going to call it user layer 8, I think. Weird physics. Or you could call this anything you wanted to. This weird physics doesn't mean anything. It just means that, you know, we're naming it that so that we understand what we're doing. In this weird physics layer, we're going to go edit. Project settings, physics 2D. And with weird physics, anytime something has anything that's in the weird physics layer, which is just essentially the two-dimensional realm where this sprite is going to be drawn, anything that's in that realm, by unchecking this box, we're telling Unity, don't make them actually touch each other. They're just going to phase through each other like it's Kitty Pryde. Anybody? Kitty? Okay.
Collision detection, is that what you're...
I'm sorry, I couldn't hear you.
Collision detection.
It's like that. It's just a built-in mechanism to Unity that you can have automatic, yeah, I guess detection.
Yeah, it's called a layered collision matrix.
Yes. So. Yeah. Now we're going to add the bird image, and going back to that tutorial page. We've got this bird animation, or this bird image that has 4 frames built into it. So I'm going to save this image as, put it in our sprites folder, and then change the import settings in Unity for it. And I believe it's a multiple on the sprite mode. That way it knows how to divide, that it's going to be dividing this into multiple images. Pixels per unit is going to be 16. Point and true color. And as I said, our bird image contains several smaller images, and so it's important that we select multiple as the sprite mode. Afterwards, we can click the sprite editor button. And you see this image contained the 4 frames of the bird animation. So in the sprite editor, we slice it to a 16 by 16 grid. Yes, everything's in Unity except, well, if I make it to the scripting is in Mono Develop, which is, you download that, it's part of Unity. But it's kind of like the cross-platform IDE for developing Mono. What's Mono? Mono is, or actually, I'm sorry, it's properly pronounced Mono because it's a Spanish guy that developed it. Mono is C#, but platform independent, and it's kind of what became Xamarin. You know what Xamarin is? Okay, Xamarin, if you're not familiar, is kind of mostly intended now for universal mobile development. So if you want to write a universal iOS and Android and BlackBerry app or Windows Phone or whatever, you can do it in Xamarin, among other things. Okay, so now I've set my pixel size to 16 by 16. and hit slice. Now I'm going to have those 4 bird images. And it'll ask us if we want to apply the unimported import settings. And apply. Okay, so now we can see our 4 slices as children of the bird image in the project area. So we go in here, and it knows how, see each one of those frames is an individual sprite now. That's, I'm thinking, a really cool thing that Unity just threw in there. So now, we're going to take the all the bird frames and drag them onto the into the hierarchy. And when it does that, it asks us if we want to put it into a folder or into its own separate component. So what we're going to do is we're going to create a new bird animation folder and save the animation as fly.animan. And the sprites, we're going to create a new folder. Create. Okay. So afterwards, we're going to see 2 new files in our bird animation folder. See, I don't think so. I think it's just for our convention so that we know what it means. No, I could be wrong about that, but I think you could call it X and it'd be fine. Yeah. So now we've got this bird in our scene. And the bird 0 file is a state machine that takes care of the animation states and speeds. The second file is the fly animation itself. And if we double click the bird 0 real quick, we'll see that the animation state machine has representation right there. And don't ask me exactly what this means, but we don't really have to worry about it because Unity just handles it. And I'm sure it's not rocket science. This is as soon as I think what this is saying is as soon as the animation starts, which whenever we trigger it to start, it does this fly animation that we just saved that shows all the frames all at once. Not rocket science. Okay, since we only have one animation, we're already done here. We press play. We're going to see the bird in action. If I go back to my scene.
You click up on the little backend thing up there, and pop back to the tab.
Game.
Why did I just hit play? Yeah.
It probably would have. Whee! So, shot of coffee. By the way, anybody been to a cookout ever? Did you guys know they had coffee? Like, if you want to go to a Starbucks or something like that and pay 18 bucks for your coffee, you can do that. But you can get this for $2 at cookout. $2, and it's awesome. Anyway, okay, back to our presentation. That was the sponsored portion of this presentation. Okay, now, sponsored by Cookout, your cookout solution. Okay, now our bird is supposed to be part of the physics world, so let's begin by giving a collider just like we did with the ground. Okay, we're going to add, go on the bird, and then add a component. Physics 2D. Yeah, okay, you know what? I think if you do it while it's playing, it won't save your results, so that's, thank you. So yeah, I'm going to go add component, physics 2D. Yeah, I've messed with this so long that I discovered that many times because I'll have it sitting there playing in the background and I go and make a change and it doesn't save it. So yeah, be aware. And by the way, it's 7 o'clock right now. I'm going to try and get to a reasonable stopping point around 7:30. Hope that's okay with everybody. Physics 2D, and we're going to put in a circle collider 2D in the inspector. Okay? So now, in the circle collider, everything in the physics world that is supposed to move around will also need a rigid body. It's already got these settings that it's got are default settings are fine. But everything that's in the physics world is going to need a rigid body. So we got to go again and add component physics 2D rigid body 2D. Okay. Now, because of the way the physics interact, I think if you don't do this, the bird will end up rolling. You don't want that to happen. So we're going to select fixed angle, so it always stays at the same fixed angle. And we can experiment with that to see what happens if we take that away. I actually didn't do that. And if you play it from here, we should actually see gravity. All right, because the bird has a mass of 1 and it fell. So now the last element to where we have something that's somewhat interactive is we're going to add a bird script. And that's what's going to handle the input and a handler to that input that makes the bird actually do something in response to user input. So we're going to add another component, new script, call it bird. Okay, and now if you go over here to, okay, see, I have the bird script selected, and then on this inspector widget, there's this little circle here. If you hit, come on, we're down too low on the screen, hit edit script, that's what opens mono develop. But does anybody ever say mono or mono in here? Anybody? Mono, okay. Well, look up, I think the guy's name is Miguel de Icaza. I think he called it mono. So if everybody in the room can agree to call it mono, then we're fine. I'll just call it mono. So edit script, and that will launch mono develop. Mono develop. And it's automatically populated with 2 functions. Start is what happens, guess what, when the bird is first introduced into the world. Update is called once per frame, and we actually configure the number of frames per second elsewhere in the IDE. But here, what we're going to do is we're going to make the bird fly towards the right at all times by adding a new speed variable. And you know what? It's a lot easier for me to copy and paste than it is to type in front of people and mistype everything. So I'm going to do that. We're going to end up with this thing, and I'll explain it as we go. Oops. Up. Okay, so what this is going to do is as soon as the bird is introduced into the world, this script finds the rigid body component that is associated with the bird and assigns to it a fixed velocity. So it's always going to, at a set speed, to the right at this speed. And you can change the speed by changing this number too. So we added, oops, you know what I did? I need to put that in here. We added this public variable speed and this public variable force to the bird. And by adding those variables, if you go back into the Unity IDE, you'll see the bird script now exposes those two things in the IDE. So you don't actually have to go into the MonoDevelop script editor and edit the values that are assigned to those variables. Because those variables are public, whatever you assign here overrides what's assigned in code. Because this happens at runtime. This happens at compile time. Okay, so very first thing was we assign a speed to the right, and next we put an event handler. So if the user touches the space button, and you just have to trust me, this is how you do it, it's going to add force up to the bird rigid body. Because there's a constant, essentially physics model, gravity, pulling down on this thing at all times, applying a force up, all it does is it's a one-time impulse force. It's going to make the bird go yeet, but then gravity's pulling it down, so it's going to go yeet and back down, like you'd expect it to, without the sound effects. So now, I think I should. That would really be awesome. Put that in there and then make it go in the App Store. And actually, the whole narration behind it, just with me saying this is what it should in the game, that would, yeah, people would download like crazy. This goofy guy is talking over the game the whole time. That's actually an idea. I like that. So if I hit play now, it's gonna run my script. Uh-oh, when I hit the ground, it stopped moving forward. But if I don't let it hit the ground, look, wait, what? Oh wait, we didn't have the camera follow the bird. So that's the next thing we do. So now, the last thing we do before we have the camera follow the bird is we'll have the essentially game instantly stop or reload as soon as you hit something. So in that bird script, we're going to add one more function, on collision enter 2D, and when that happens, we're going to tell the application to reload the currently loaded level. And this interface that this method implements is automatically detected, and it's one of the really magical things about Unity is if you implement a method that it knows you are part of the overridden functions, then it automatically calls it and knows what to do. So this function is automatically called when the bird object collides with something. And we could look and see what it's colliding with, but we don't really care at this point. So I'm going to save that, go back in, and hit play. Guess what? As soon as I hit the ground, it's going to restart. So now, okay. Now what we need to do is add the camera follow onto it. So right now the camera never moves. Since the bird always flies towards the right of the screen, in this version, we won't be able to see very long. So we need to solve this problem by creating a new script that makes the camera follow the bird all the time. So let's select main camera in the hierarchy and click on Add Component, New Script. This is the best part. You're missing the best part. It's fine. I'm just a half on you. She doesn't need that iPhone. She doesn't need it. Okay, in that case, fire the iPhone. Okay, so we're going to go onto the main camera, and we're going to add a component, a new script. We're going to call it camera follow. Okay, and then again, we're going to go and edit script. on the IDE. And again, it's populated with the same to start and update. This is called when the camera's inserted into the world, and this is called every frame. So what we want to do is, first off, we're going to delete the start function because we're not going to do anything at initialization time. And then on the update, we're going to make this thing follow a target. And again, I'm going to copy and paste. And I'll explain this when I throw it in there. We're going to set, okay, when update is called, every single frame, we're going to set the transform position, the transform object's position field, and the transform is a member of the camera follow class because it's a mono behavior, which is the game object. The transform of the camera follow object, we're going to set that position to the target object's position X and leave the Y and the Z as the same as they were. Well, where does target get set? What we need to do, well, I didn't even put it in there yet, did I? Now we got this probably transform target. You go back into the IDE, and you look and see the target automatically appears. We're going to set this to the bird, right? Yeah. Okay, so now if we play, what do y'all think is going to happen? Hopefully, it's not going to die. Yep. See, the camera is now moving with the bird. Now, this is kind of a retarded way to handle it. There's nothing at the top keeping it from going higher and higher. So if I keep, it's never going to come down now. I mean, it's just going to. Oh, and look, there's the end of the ground. Okay, yeah, I'm just going to stop. This could take forever. Okay, so now we have a flying bird moving forward. We have the camera following it. We have the ground underneath it. What we saw in Flappy Bird, in at least a version of the original, is these obstacles that make it hard to keep going because you can't just keep going. Oh, no. And I made it 1. What's the highest score anybody ever got on Flappy Bird? Anybody?
63. Whoa.
You're my hero, man. I can't do it. I've gotten maybe 4. Maybe. Yeah, is that a platinum medal? What is that? Is that a gold medal? That's awesome. You bragger. Oh, okay. We're not worthy. Okay. So we need to add obstacles. Tutorial. Oops. Which is here. We're going to find this image. I'll click on him. Save image as. Put it in our sprites folder. It's going to be called obstacle.png. And change, we're going to go back to the inspector in the IDE and set his import settings. 16 pixels per unit. Filter mode of point and format of true color. And you can Google what all that means. It's pretty straightforward. Unless you don't know images, but whatever. Okay, so now we're going to drag the obstacle from the project area into the hierarchy in order to create a new game object from it. Oops. Okay, so there it is, and it's kind of overlapping our bird. So all we need to do is set its position to, let's try values. Okay, if we move it forward 1, it goes there. Okay, well, 2, 3, 4. Let's try 3. So he'll hit it pretty soon if he doesn't stop. And the Y position, again, 1, it moves it up, -1, -2, -4. That's a good place for it to be because that means it'll have to flap in order to get over it. But -5 is okay. So now that's basically what we're going to start with. The only thing we have left to do to make this kind of interactive is add some physics to this obstacle. Because right now, what I said, well, let's just see what happens if we don't do that. Oh, wait. See, you can touch it and it doesn't matter because it's not really there. Actually, that might be just as fun. I don't know. Yeah. Well, that's about as fun as the version I wrote. So you can do that too. So in order to add a interactivity to it, we'll add a physics component to the obstacle. So we're going to go and say add component physics 2D box collider. Box collider. And I think the default values are right. So it automatically detected how large it was, so we don't have to do. I mean, this Unity's magic. I mean, it just knows exactly what we wanted. Now, if we set the layer to weird physics, then that means that everything in the game will touch it, other than other elements that are in the weird physics layer. So play that again. See it hit it. Okay. So now we got basically a nice little interactive start. Okay, from there, so some of the obstacles are supposed to move up and down. That's just the way we're going to start this thing. Everything in the physics world that is supposed to move will need a rigid body. That's the other rule in Unity. Is like you got the colliders that cause it to have something to interact with other things, but having a rigid body gives it mass. So we're going to add a rigid body, going to add component physics 2D, rigid body 2D. Okay, and it's going to have a mass of 1. And the gravity scale, okay, the gravity scale we're going to change because we don't want this thing to be affected by gravity. We just want to be able to control it and move it where we want to. We don't want it to have any exterior forces inflicted upon it that make it move in any other way than we want it to. So we're going to set its gravity scale to 0. So even though it has a mass of 0, a mass of 1, I think we could also set that mass to 0 and probably have the same. Well, no, we want it to hit things. We just don't want it to be dragged down by gravity. So it needs to have a mass, but not gravity. Okay, so we're also going to set its fixed angle. That way nothing makes it twirl around. Actually, you know what, I'm going to see what happens when we don't do that. That's what we're doing, right? Oh, it did that because it had some kind of interaction with the ground. Weird. So even though it's weird physics, it still wanted to fix it somehow. So we change it to fixed angle. Okay, I've done something wrong. It's making it, yeah, it's forcing it up out of the ground. I don't know why. What did I do wrong? Okay. Okay, so we don't want it to be, say what? Mass 1, linear drag 0, angular drag 0.05, gravity scale 0, fixed angle, kinematic, interpolate and unstay awake.
I think your issue is you have two objects in the same layer. You have the ground weird layer and this weird layer.
Right, but
The ground piece is being forced into that position at one time. It's bouncing back up. Is what you're seeing.
that's certainly what it looks like, but I've done something wrong because it didn't do that when I first wrote this thing, and it doesn't do that in the demo. So there's some step that I've missed.
Or do you have to do the script that's next? Or
Maybe, yeah, let's do that just to, maybe that's all that needs to happen. So, because actually the instructions don't say to press play at this point, so maybe that's all it is. So we're going to add a component, and honestly, I didn't try playing it there last time. And a new script, and call that obstacle. This will be the script that controls the column moving up and down. Create an add, and then we're going to go edit script. And you see, just like the other two, it's got a start and update. And what we're going to do is add a few things. First off, is this, we're going to have a public speed variable, a public switch time variable, and then at initialization, we're going to set the speed, set the velocity, which is the speed and the direction of the object, to be vertical. It's moving at whatever speed you set it to. This invoke repeating will call the switch function every 2 seconds, and it will change the velocity to be the inverse of what it is. So put that back in there. Oops. Yes, I'm cheating. Now, let's save the script and go back into the IDE, and you see these two new variables that were added to the script: speed and switch time. So if we set the speed to 1, like I said, this will override whatever's set in the code because this is set at runtime. Oops. Now if we press play, cross your fingers. Oh, it's still interacting with the ground somehow. Okay, so I've definitely messed up somewhere. Oh well. What did I do wrong? It's probably with the ground. Let me see if there's something I missed on the ground.
well, the other thing I see is you missed that late. But it doesn't seem like that. No, that's correct. This is late update for transform position.
I don't know.
What happens if you move the ground on the layer, same there?
So we can try that. But then there.
Oh, it is on the same.
Say what?
Oh, it is on the.
The issue is that that object.
Oh, it is on. You're right. The ground is supposed to be on weird physics. Okay, yeah, that's definitely the problem. Okay, so there we go. Okay, thank you for your help. Now, okay, so now we have that thing moving around in the background, and I won't point that out.
So why did you ground announce?
I'll get to that in a few minutes, but essentially, there's no the ground is a fixed image, just scrolling from left to right, and as the camera moves, we go past the image. We would have to make something replicate the ground to make it not go away, and there's a few ways to do that. Where are we at? We're at 7:25. We got just a few minutes. I'm going to cover the obstacle replication, and then I'll jump to that. Okay, so we got the obstacle physics. Now we're going to add more obstacles. So let's go into the obstacle, into the hierarchy. Right-click on hierarchy. Right-click and say duplicate. Okay, and you'll see that in the hierarchy, it created this other obstacle 1. So now we're going to move it. Let's change his scale.y to -1. No. Right. Scale.y to -1. And 0, 0. No. Set his Y to 4, 5, 6, and his Z. Yeah, so it's basically right at the right place. So what this is going to do now, I've got the 2 obstacles in there. They're both moving in the same direction. Oh, and I'm equally bad at this game as I was on the real Flappy Bird. So now I've got 2 obstacles, but they're all in one place. They're not ever going to move. Well, they're not going to move in the X direction. So now we can add as many obstacles as we want to make this, kind of look more like there's more stuff into it. So right-click on obstacle, say duplicate, and duplicate again. Oops. Again. Okay, so obstacle 2. We'll set his X to 5. How about no? 8. There. And obstacle 3. Just making set his X to 8 as well.
Do you make groups of obstacles so that
You could. And there are really there are probably a dozen different ways to do the same thing. And actually, if you look the way that I did it in my code, on the example, like when I took this and ran with it, I only created the one. And actually, I'll go ahead and get into that right now. I only created one obstacle in the IDE, and then I programmatically duplicated them 20 times or something like that. and I'll show you guys that in a second because we're about out of time. So now these are, I stink at this game. Did you guys laugh at me? No. Oh, yeah! Oh! Okay, I just can't, I cannot win, I can't. So I could either keep going with this, or I'll show you guys where I went with when I took it and ran with it and kind of went another direction. Okay, well, you guys saw that we started with basically the same kind of template on the other one, but in my world, I didn't think it really made any sense to have the same objects in the IDE repeated a bunch of times. So I did in the bird script, which is here. I said, okay, I'll get into the handlers in a second. I created a private member variable in the bird object, which is a collection of obstacles on the top and on the bottom. Okay, and so the very first thing that I did was I placed the bottom obstacles, and you go and find the object named obstacle, and then I add it to my collection, and then I also created a collection of top obstacles, the ones that are above, and I just translated it by 13 in the vertical direction. And then I created 9 duplicates, so there's 10 total of those obstacles, and they're each offset by let's see. So the X they're translated, they're offset on the X direction by 5, and the Y translation, I didn't want it to be fixed, so it actually will be different every time you run it. It's a random number between 0 and 8 minus 4, and that way it can go between +4 and -4. And that's about it with regard to the obstacles. The other question you asked was about the ground. What I did in my solution, and again, there's different ways to do this. I said, okay, at runtime, I found the ground and then I created 1 duplicate of it. So as soon as you get to a reasonable X offset, make sure that ground is in front of you. The next one is in front of you, and then when you pass over it, the next one is the current one, and this one is the next one. If that makes any sense. So it's actually right here. As you're flying around, I say, okay, on this frame update, I get the difference in position between the bird's X position and the ground position. The difference is greater than 50, which, at that, it just happens to work out in this world. Then that's when I trade them. That's when I put the one that was back here up here. And so it's constantly just putting this. But it only does it, until you move far enough to head to where you need to. And actually, you'll notice I have an absolute value instead of being if the difference is greater than 50, then it would only do it in the right direction. But because I'm doing it in an absolute value, what that does is if I'm going to the left, which I'll show you in a second, it adds it puts it on the left side instead of the right. So, anything else on this that I should show you? Oh yeah, the interactivity. Okay, to support a mobile platform, you kind of have to accept inputs that are other than your keyboard. Like on the keyboard, you expect a space key or a left key or a right key, and that's how I was interacting with that other one. It was just left and right and space. But on a mobile device, you don't have a space or a left or a right. So you have to do a little bit of magic to detect a swipe left or a swipe right or a swipe up or a swipe down. And do I have visor running? Here it is. Okay. Okay. So if I hit, if I go in and I've run my Flappy Bird. Oh, wow. Okay. I didn't anticipate this. So it doesn't look like that here. It's oh, there. Okay. Okay. So now, darn it. But oh, it's reloading it every time.
It's really hard. You flipped your phone.
Didn't I just? Well, I should have thought to put this on an emulator instead. So if I change this, can I make it portrait mode? Well, okay. Rather than showing you on the mobile device, I'll just show you back in Unity. It's about the same thing. As soon as I hit play, oh yeah, the sound. I didn't mention the sound. That sound is literally me going. I just recorded that and then put it into an MP4 file. And I added in handlers to where if I hit left or right, it increases the speed. And you know what? There is supposed to be a score text on there. I don't know. Okay, there's a score text on my mobile version. Somehow I didn't save it or something like that. There it is. Okay, well, you just have to trust me. I'll show you. You guys can come try the other one, but the one that's on here. I think it works. Maybe not. Maybe I compiled a version that didn't have the score text in it by accident. So the way it works is I'm keeping, yeah, it's in here. It's keeping track of the score on the bird object, and the faster he moves, the greater the score is. So if you go up really fast, that increases the score a lot. But that's not really what I had in mind. I should have just done it instead of magnitude. I should have done it just left or right. But so the idea is if you're moving right at a pretty good clip, then that's going to make your I'm not so bad at this game when I can bump into things, you know. And the way these obstacles work, you'll notice that these guys are kind of wobbling left and right. That's because I bumped into them before. As soon as they go off screen, Like as soon as I'm all the way up here, the ones that are back here, I move them back forward. So I don't have an infinite number of colliders just getting on the screen. And that's pretty much it. I mean, like I said, I've got the score in there. There's no adware or anything like that. So, you know, you want to take this and make some money off of it, go for it. Give me a, I don't know, royalty or something like that. We're actually giving New Duds a royalty because he's the new who put it out there. You can see the version that's on my Android phone, and theoretically you could compile this and put it on any device. You could put it on an Xbox. That's one of the great things about Unity. You can compile it and target it to Windows, Xbox, BlackBerry, Windows Phone, whatever. You know, iOS, Android, anything, and it's all the same. You know, it literally is write once, run everywhere. It's not so hard to get it to run everywhere like it is other languages that tout that principle. So that's really it. By the way, the one thing I didn't really say anything about was the sound. There is some extra magic you have to do to make the sound play. It's almost as easy as just adding in one of those physical objects into the world. You add an audio source into your components, and then in your update, in your on update function, you say if the user did this, then play the sound. Good. That's it. Anybody have any questions?
Does Unity provide anything for like handling state when you rotate? Like, I don't know if you've been like Android native development where you have to keep track of state.
Yeah. So if the screen rotates from this way to this way, you know what? I honestly haven't ever tried. In this on my IDE, I told it to specifically only run in landscape mode. So when you go build settings, you tell it what platform you're going to target. And on this one, for player settings, I told it to only allow landscape right and landscape left. So that's when it's, you know, I said portrait meant landscape.
You can detect that.
But you have to keep track of state and use your spot.
No, it absolutely does. You can detect that from time. There is an inspiring whatever. If anybody has any Unity questions, hit me up. I can probably answer anything.
The Unity guy,
The expert.
I'm not the Unity guy. I mean, I think it's cool. I'm just a noob.
Joseph, as this demo is, as he does it, so you do run out of ground?
On my game, you do not run out of ground.
No, I know on yours, because you fixed it.
Yeah.
On the one, the stock one that he sort of provides.
On Noob Tuts, the ground just goes away, and then you're done. But it's not that hard. Like I said, once you get to a certain point, I have essentially a FIFO that
Right.
when this one's too far, just replicate this one and move it back over here. Or if you're going backwards, it does the same thing forward.